Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Batrisha binti Mazrul Hisham, metric number A194528. Today I'll present to you the thesis that I obtained thanks to Dr. Nurul Ain binti Abdul Jalil. Determination of nutrient concentration rate and heavy metal content in the Supplier River of Tasik, Chini, Pahang. This presentation consists of 5 parts, which are abstract, introduction, methods, result and discussion, conclusion, and lastly is reference. Next, for the abstract Tasik Chini is surrounded by 9 rivers, faces nutrient and heavy metal pollution from nearby mining and logging activities. This study was conducted to determine the rate of nutrient concentration and heavy metal content in Tasik Chini and Sungai Chini. Among the parameters tested at the 6 sampling station were pH, dissolved oxygen, ammonium nitrogen, phosphorus and nitrate, as well as 7 heavy metals which are cadmium, copper, lead, zinc, manganese, iron and chromium. Results show high iron and manganese levels, particularly near human activities, indicating pollution hotspot in Sungai Chini, Sungai Jemberau and Sungai Melai. For the introduction, the increasing rate of urbanization, industrialization, and global population growth has escalated environmental population problems. The study examines nutrient concentration and heavy metal content in the river supplying Tasik Chini Pahang. Human activities like waste disposal, mining, agriculture, and logging are major contributors to water pollution, which impacts water quality and ecosystem. Focusing on anthropogenic pollution, the study highlights the challenges in monitoring point sources, factories, sewage plant, and non-point sources, agriculture, runoff, logging. High level of heavy metal and nutrient in water can harm aquatic life and alter water properties, posing serious health risks to human and wildlife that depend on these water sources. Understanding this pollution dynamic is crucial for developing effective strategies to protect and manage water resources in the region. So those are the methods. The first one is sampling station. It is conducted once in December 2019 during the rainy season. Data from January and February 2020 obtained from the Tasik Chini Research Center. It is located at 6 stations, which are Sungai Gumung, Sungai Jerangking, Sungai Melai, Sungai Chuk, Sungai Jemberau and Sungai Chini, and 3 samples taken at each station. Number 2 is sampling method. Location based on PPTC coordinates and GPS. Station 1 Sungai Melai, Station 2 Sungai Chuk, Station 3 Sungai Jemberau, Station 4 Sungai Gumung, Station 5 Sungai Jerangking, Station 6 downstream Sungai Chini. Samples collected 1 meter below surface in opaque amber and polyethylene bottle with 3 replicates per station. Number 3 is determination on of in situ parameters. Parameters pH and dissolved oxygen. For measurements at 1 meter depth using H multi-probe instrument. Instrument calibrated for accurate readings. And number 4, determination on of ex situ parameters. Heavy metal is measured using ICP MS. Phosphate measured with Fosford-3 method using HDR 2010 spectrophotometer. Nitrate measured with powder pilocadmium reduction method. Ammonium nitrogen measured with Nestle 8038 method. And number 5 is statistical analysis. Data analyzed using one-way and two-way ANOVA. So next is result and discussion. Figure 1 shows pH readings of water samples based on dates and 6 sampling station. It shows pH variation from 5.18 to 6.89 across 6 station and dates. The lowest pH was at Sungai Gumung and the highest at Sungai Chini. Significant differences in pH were found between dates but not stations due to rainwater runoff carrying metals and organic matter, making the water slightly acidic. Figure 2 shows dissolved oxygen reading milligram per liter by dates and 6 sampling station. The lowest dissolved oxygen was at Sungai Jerangking and the highest at Sungai Jemberau. Significant differences in dissolved oxygen were found across date but not between station. Higher dissolved oxygen support aquatic life, while lower dissolved oxygen less than 3 mg per liter is harmful. Sungai Jemberau had higher dissolved oxygen due to faster water flow, and February rain increased dissolved oxygen by enhancing current. Lower dissolved oxygen at Sungai Chini was due to organic waste consuming oxygen. Next, figure 3 shows the reading of ammonia nitrogen milligram per liter at 6 sampling station. The highest average concentration is in December and the lowest is in February. Sungai Jerangking and Sungai Chini had slightly higher average ammonia nitrogen levels influenced by agriculture runoff and organic matter degradation remain below WHO limits, which is 0.9 mg per liter. Figure 4 shows average nitrate concentration milligram per liter readings across 6 stations. Sungai Chini had the highest and Sungai Chok is the lowest. Nitrate sources include farms, sewage, waste, rocks and runoff. Sungai Chini collects upstream nutrient and heavy rains increase level due to river backflow. All readings are below the 10 mg per liter drinking water standard. Figure 5 shows average phosphate concentration milligram per liter reading across 6 stations. Sungai Jemberau had the highest average and Sungai Gumum is the lowest. Significant differences were found among stations. Phosphate from sewage and agriculture can cause algae growth and eutrophication. Logging activities, especially at Station 3, increases level due to fast water flow. Station 3 and Station 6 shows moderate phosphate pollution, which is 0.20 mg per liter, requiring further study. Figure 6 shows comparison concentration of heavy metal in water samples across 6 sampling stations. It shows toxic heavy metal accumulating in the food chain from natural sources and human activities, like industrial waste disposal. Iron, manganese and zinc are the highest, while chromium, copper, lead and cadmium are the lowest. High iron and manganese level are due to natural abundance and activities like mining and agriculture, with rainfall and runoff increasing their presence. Pollution is concentrated in the south near mining and agriculture sites, especially at Sungai Chini. Overall, pollution levels are within limits, but iron and manganese are moderately high. For the conclusion, the study evaluated nutrient and heavy metal levels in the rivers supplying Tasik, Chini, Pahang due to declining lake water quality. It found low ammonia nitrogen and nitrate levels, slightly elevated phosphate level and moderate phosphate pollution, especially near Sungai Chini, Sungai Jemberau and Sungai Melai. Influenced by monsoon and dam construction, human activities like agriculture waste disposal, land clearing and logging also affect nutrient level, while most heavy metal were below pollution benchmark. Iron and manganese show moderate pollution due to mining and logging. To protect water quality, stricter environmental regulation, better waste management and continuous monitoring are essential. So here are the references that obtained from the thesis. That's all from me. Thank you.